So let's have a look at the things you should know for the vectors test. So first of all, you should know how to get the components of a vector if you're given the coordinates of point A, say xa, ya, and the coordinates of B, xb, yb. Now vector AB, written like this, has components xb minus xa, comma, yb minus ya. So what I've done is I've taken the endpoint coordinates, and from that I've subtracted my start point coordinates. Next, let's say you are given some vector u, and it forms a angle with the horizontal of theta degrees. Then another thing you should know how to do is how to get the components of this vector. So here I'll draw the components in yellow. Now the horizontal component, which I'll call the x component, is equal to the magnitude of u times cosine of theta. So this is SOHCAHTOA, right? Because if we do the cosine ratio, we have adjacent, cosine of theta equals adjacent over hypotenuse, but we know the hypotenuse is the magnitude of u. And the y component is the magnitude of u times sine of theta, also by SOHCAHTOA. Another thing you should know is how to find the magnitude of u. So magnitude of u is equal to, suppose you have components x and y, then it's x squared plus y squared square root. So this is just Pythagoras, right? If this is a 90-degree triangle, and you know the x and y components, then to find the magnitude of u, you're going to do this squared plus that squared square root. Another thing you should know is the cosine law. So suppose you're given a triangle. Call this angle C, angle A, angle B. Call this little c, side little a, side little b. Then little c squared equals a squared plus b squared minus 2ab times cosine of the angle between them. So here we go, theta is right here. So this is the cosine law. The sine law is, say, you do sine of angle A over length of A. That is supposed to be equal to the ratio of sine of angle B over length of B, and it's also equal to sine of angle C over length of C. So this is the sine law, and this is the cosine law. Both very useful. Another thing you should know is how to calculate the scalar product. So let's make a little box here for the scalar product. Suppose you're given two vectors, u and vector v, and the angle between them, theta. Then there are two ways to calculate the scalar product. The geometric approach for the scalar product, which is u dot v. The geometric approach is you take the magnitude of u, multiply to the magnitude of v, and you multiply that to the cosine of the angle between them. The algebraic approach is you take the x component of u, you multiply to the x component of v, and you add that to the y component of u times the y component of v. Now, since these two are the same scalar product, that means that the right-hand sides are actually equal to each other. So if I were to rewrite this, it would look something like this. X of u times x of v plus y of u times y of v equals magnitude u times magnitude v times cosine of the angle between them. So you can actually equate the two. So if you know the components, you can find the magnitude using this formula up here. You can find the scalar product using the algebraic approach, and then you can solve for theta, the angle between them. Next, next you should know how to do the projection. Now I'm not going to derive the formula for you right now, but the formula for projection is projection P equals, so given these vectors here, u and v, let's make this projection P here. Projection P is equal to u dot v, so the scalar product, divided by the magnitude of v squared times vector v. So this is the formula for the projection. Something you should know. I've made a video already on how to derive this formula. If you want to see how it's done, you can definitely look it up. And of course, you should know how to add vectors. Basic vector addition is you add the x components with the x components, the y with the y, and the resultant is therefore the sum of the x components, comma, the sum of the y components. And I think that's it. If there's anything else, I'll post it in a second video.